This week on The Agent Factory.
We're thrilled to have a special guest, Philipp Schmid, for Google DeepMind.
Ship, iterate, with vibe coding and APIs and API keys being accessible, you can easily scratch out a proof of concept for some kind of agentic use case within a few hours.
Hi everyone, and welcome to the Agent Factory, the podcast that goes beyond the hype and dives into building production-ready AI agents. I'm Shirmeir Lador.
I'm Ivan Nardini.
And today we're thrilled to have a special guest who is a leading voice in the AI community, Philipp Schmid. Philipp works in developer relations for Google DeepMind and is the author of an incredibly popular technical blog on AI and agent development. Philipp, thanks so much for joining us today. How are you?
Hi, yeah, thanks for having me. I'm doing great.
That's great to have you, Philipp. And because you're here, today we are going to have a special episode. So we are going to skip the industry polls and we will dive directly into the show of the factory floor and the developer Q&A. So we can tackle some of the most practical and common questions that developers out there, as you're having in agent development.
Exactly. This episode is meant to be a playbook for developers looking to build agents that actually work in the real world. And for everyone listening, by the end of this conversation, you will have a solid understanding of how to choose the right model and the right framework. What are the necessary things to watch out for in your agent development to make sure your agent will really work in production, like the agent pattern, the context engineering, effective evaluation. Plus, we will get some pro tips about Gemini CLI from Philipp.
Yeah, that's right. We are going to cover everything from picking the right model to building a reliable agent. And if you think we are sharing good content, as always, don't forget to subscribe to the Google Tech channel, like the video, and drop your comments.
And before we get started, we're excited to announce a new event series called Accelerate AI with Cloud Run to help you take your AI agent from prototype to production. You'll learn how to deploy scalable, secure, and production-ready agents. In the link to the show notes, you can find the North America schedule and register. And stay tuned for the more global locations.
Okay, I think we're ready. So let's get started.
All right, let's get down to the factory floor where we build and break down the core concepts of agent development.
So, Philipp, I want to start with a very simple question. So you have this long history of testing large language models, both open and now proprietary models. So in your opinion, why should I consider Gemini as a model to build agentic applications?
That's a very, very good question. First of all, I would say Gemini is still very unique in the whole foundation model space. All of the models are kind of approaching the same level of performance, but Gemini is still, I would say, is very special in terms of supporting 1 million token contexts. We now see competitors kind of catching up. We have very strong multimodality support with image input, audio input, video input, which I find very exciting. And then of course also multimodality output. And Gemini, and especially with Gemini 2.5 Pro and 2.5 Flash and 2.5 Lite, we have this reasoning and thinking capabilities, which give the model way more time to think or generate tokens to solve a specific use case. So if you have a user agent trying to support your customer support, the model now has way more time to compute and to understand the use case. And with the bigger context window and supported multimodalities, you can include much more information to solve the user specific task.
I see. So large context window, much longer time to think. All of these are really great agentic capabilities as well. Are there additional specific agentic capabilities that Gemini provides?
Yeah, so what is very unique, I would say, about a Gemini API, so when building agents, you normally have something called function calling or tool use, which basically forces the model to stick to a structured output. So you can think about you have an input and the model tries to either return a normal response or to generate a structured output. And the structured output could be a JSON, which you can then parse and use for doing some kind of code execution. And with the support of the longer context on the more time to think, we have something or a lot more room for the model to find the right answer. I think that a few years ago we called it prompt engineering. Now we call it context engineering. And the whole like concept about context engineering is that we give the model the right information at the right time with the right tools to solve our users' task or goal. And with tool use and built-in tools like Google Search, we have function calling capabilities and structured output, which we need to kind of interact between model and the environment. We have the big context window, which allows us to provide way more information about the user, the task, previous conversations, previous use cases. And then, of course, we can not only provide text, we can also provide images, video, or audio, which makes it way more easier and accessible to build those real-world agentic use cases, because we are like not all sitting in this like chat window where we have like a text input and a text output, and then every user is kind of happy.
Yeah, but so, I mean, we are all agreed that Gemini is a very capable model, right? But for example, one of the features that, or the capabilities that you mentioned, which is function calling, you can also reproduce it with an open model, right? Maybe you can fine-tune an open model and get the same capabilities. So my question is, let's assume that I want to use an open model then. So when do you think I can consider it for building agentic applications?
When you should like consider an open model compared to Gemini?
Correct.
I think like, so what I always try to recommend to people is like, we all want to build cool applications, right? And we want to start very easy, very fast, and not needing to pay like thousands of dollars. And having like an API access through like, for example, AI Studio, where you can like generate an API key within like less than 30 seconds and then start sending in a request to Gemini, is like super easy for every developers to start. JavaScript, Python, Go, normal Bash, normal HTTP, all of those method works where you can start building an agent. An open model is really nice if you are constrained to certain environments. So an open models, of course, offers the benefits. I can run it on my local device. I can run it in my own environment. So if you need to work in a more constrained environment, you can start building an agent using an open models. Of course, this comes with like different challenges. Open models require more compute to run, so your upfront cost might be a bit higher than starting through an API. What I always try to suggest to people is like start with is the easiest path for validating your proof of concept, right? At the end, it doesn't matter if you validate your use case using Gemini or like Gemma or another open model, because like the capabilities kind of align slowly, that open models can be used for the same kind of use cases as those foundational models, but those are way more accessible for people to start with. And I guess all we want to validate in the beginning is like, okay, the use case I have in my mind, is it even like possible to create and realizable before needing to rent or to buy like GPUs or TPUs to run my model?
I see. So using like your suggestion is start with the API, try to implement the application that you have in mind using the capabilities that the API provide. In this case, the Gemini API, and then if you want to reach a higher level of customization or you have some specific requirements, then you may want to consider also open models in some scenarios.
Yes, I guess like whatever the fastest way is to validate your idea is something you should pursue. And with vibe coding and APIs and API keys being accessible, you can like easily scratch out a proof of concept for some kind of agentic use case within like a few hours or days, which makes it very easy to present something to your team, to your leadership on validating an idea, right? That's like
for sure.
4 or 5 years ago, we didn't have those capabilities where we needed to invest way more time in like the concepts and like the documents we present. And now we can like just code a proof of concept and go with the proof of concept to people and have them understand like, what can we build? What should we build? How does it work? Or how could it work?
Yeah, I think it's very interesting what you're describing, because as someone has been in this field for so many years, I think like if you've been, and Philipp, I'm sure you have as well, and Ivan, like we have been usually very focused on fine-tuning, training our own models for specific applications. And now there's a really big shift when you first go to what's ready out of the box, like Gemini, calling that API, you try to build a quick POC, and then you figure out whether you need to actually, fine-tune your specific model. If you like, in most cases, the ready-made API, those big LLMs are kind of controlling the AI application field. So that's an interesting observation that I'm seeing. And also, I think, Philipp, you recently released a Gemma 3 270 million parameters. They're very small models that can run on edge devices. And I know it's very compact, it's hyper efficient. What is your point about, what are your thoughts on smaller models? Because as I said, in the past, this was the main, AI kind of application. They were all based on smaller models, and now we kind of transition to this larger models for everything. Like, do you think there's a situation and we shift back to using more and more small, expert fine-tuned models for specific use cases instead?
Yeah, so I'm very excited about like open small models, mostly because I will soon be able to run them on any device in my house. I have like a smart home assistants, and they feel very dumb to what AI models can do today. And I hope with all of like the improvements on like foundation models and like open and small models, we see a lot of more improvements on those like devices and use cases. I think there's like so many more possibilities we will have in the future with better, faster, smaller open models. And I think like if you are longer in the AI space, you see somewhat of a trend with models being small, models becoming big, more powerful and more performance, models becoming smaller again, but same level of skill, models become bigger again, models become smaller again. So there's a very seeable trend that we get bigger models, which are better, then we get smaller models, which are cheaper, but have the same capabilities, bigger models again, which are better than the previous generation, and so on and so on. So we will see better, smaller open models, but we will also see better, bigger, open and closed models. And I think with Gemma 3 207 million parameter, it's like very exciting to see what a community can come up with in terms of use cases. I think now it's like 7 years where Google released BERT, which was the first production transformers type architecture model, which became like super popular in like the whole ML ecosystem. And Gemma 3 270M has 270 million parameters. BERT back then had around 110 as like the base model. So we are going back to roughly the same size, but we have now way more options and like capabilities what we can do. Of course, the model will not be as good as Gemini in your browser where you can ask it basically anything, but it can be very good for a very handful of use cases if you fine-tune it. And especially with like the low compute requirements, I think it takes only around 500 megabytes on basically any device. So it can be on your phone, on your computer, it can run on a Raspberry Pi basically, and probably soon on like any smart device. You can have very good use cases for information retrieval, for structured outputs, basically having an unstructured text and converting into some JSON, doing classification. Of course, all of those use cases which we used to do with previous generation models are now capable with those smaller open models or better models, but way easier to do and way easier to fine-tune as well.
So I would expect that you will let Gemma 3 to control your curtains in your home.
I hope.
That will be cool. Yeah, so we're talking about open models. Assuming you play with open models yourself, do you have any favorite one from your perspective?
So like my most favorite open models, so I have a MacBook Pro and I really like to run Gemma 3 12 billion parameter, which is like the middle-sized model. It's like super fast, but it's like still very capable on like what it can do and what it can suggest. Most of the times I of course use Gemini through AI Studio because it's same accessible. I have always an internet connection, but when I travel or on the flight, it's like still mind-blowing to me that you don't have any connection, you run an AI which basically still compresses the whole of the internet on like a super small footprint, and you can ask it like questions about coding, you can ask it questions about all of the world knowledge, and you get back a very proper response.
Mm-hmm.
I see.
So, switching gears from models to agentic frameworks. In the first episode of this podcast, we talked about LangGraph and CrewAI and ADK. We wanted to get from you, Philipp, what is your take on different agentic frameworks? I know you wrote about it in your blog. When should people consider using each of those? What are the pros and cons that you see?
Yeah, so I'm like very happy that we are now collaborating, I think, with around 20 startups and open source libraries to make Gemini way more accessible to the developers. And we really want to enable developers to use the tools they are most comfortable with, right? Some people started their AI journey using LangChain or Llama Index, which were one of the first like libraries, and like stick with it. And now with LangGraph, they have like a composable framework. CrewAI was, I think, one of the first pioneering the whole like multi-agent kind of infrastructure. We have now Pedantic AI, which includes the Pedantic data structure model, which makes it very nice to work with structured data. I think there are like many great libraries out there. The benefit of using agentic frameworks and libraries is that you will be probably faster to prototype something. There will be communities and examples, which helps you to understand, okay, is there already an example built for my use case? Can I get some inspiration? Have people run into like the same kind of issues, right? We still write software, so we still run into like the same kind of issues, errors, bugs we do with like other like libraries. So the bigger there's a community or the more people use something, the easier it is for me to get help. Of course, an agent is just a while loop, but it is a lot more, right? How do I want, or how do I handle monitoring or observability? Do I care? Do I not care? And if you include all of those like different topics, which I need to build like a production agent, I can gain a lot of like benefits and value from using agentic frameworks. And then I guess it goes down to like personal preferences and like design principles. Like many different agent libraries are opinionated. Maybe I prefer like the structure from Pydantic over through LangGraph. Maybe I'm not. I think the right answer is to definitely try to get some kind of understanding of what they do and like choose the one which fits your personal style of coding, your company style of coding, or even your use cases. Llama Index, I know, is much more focused on like document processing and have a lot of great resources on how you can scale those typical enterprise document processing pipelines. CrewAI has like a lot of great examples and ideas on how you can like have multiple agents interact with each other. So I would say there is not like the one perfect framework, and it really goes down to like personal preference. And I think it's great that we have such a thriving open source ecosystem for agentic libraries and frameworks.
Yeah, no, I mean, I'm completely aligned with what you share. In fact, we discussed this in the first episode. There is no one framework that rules all the possible use case. I'm just wondering, because you probably play with a lot of them, like you tested with Gemini a lot of these frameworks, like what the roadblocks that you face, the main one that probably developers that are watching us or listening us, they are facing as well, and how did you like manage them?
Yeah, I think the big challenge we have with building AI application and agents compared to traditional software is that the Hello World example we can now create is much more magical than it used to be, right? When like thinking about building a microservice, like setting up a web service and doing like a ping pong kind of request was not impressive. And now like the Hello World example for like an agent use case or library takes like 30 minutes to set up, and you have like a chatbot which can talk to your docs, can Google search, and can maybe like interact with you per voice. That's much more impressive and gets you so much more in like a short frame of time. But when you then like start looking into, okay, what are my use cases? What are the guardrails? How can I like test it, right? When we work with agents, we often manually test. We interact with it. We send some prompts. Maybe we have like a list of like top 10, 20 prompts, use cases we want to solve. And that's oftentimes not enough. LLMs are non-deterministic. So even if I would ask Gemini a million times what is the capital of France, there still be a chance that it might answer not France, just because of how the models are structured and work. So I really need to think about all of those new kind of challenges. From evaluation is much more different. How do I handle observability? Because like we still have this kind of data drift concept, right? I mean, you might have seen it yourself when you interact with Gemini or like another chatbot. Your expectation on what the model can and will do will shift over time. In the beginning, we were all super impressed by having a chatbot write us an essay about 200 words. Now we like basically provide a whole lot of context and tell it like, please go and solve cancer or something. So our expectations to AI like shift while we are using them, and the same will happen to your users. So even if they're like super impressed on like the first demo, they will have higher expectations over time very quickly. And you need to understand how you can measure them, how you can track them, how you can scale them. And then, of course, is something going out of the way, and how can you optimize those different prompts? So I think the importance of observability, monitoring, evaluation are becoming basically the cornerstones of building good agentic frameworks or applications, and not which framework you will pick or which model you will use.
Yeah, I mean, these concept, especially the evaluation one, is keep coming back to this podcast. I think we should plan an episode.
Yeah, we should. I think we have one planned out for evaluation, definitely. And I think back to using open frameworks to build agents. Recently, you and the team in DeepMind released the Deep Research agent. Can you tell us a little bit, like you talked about challenges, can you tell us a little bit about how you go about building this kind of an agent?
Yeah, so maybe quickly for the listeners, if you are not aware of like what we mean. So we build a quick start example on how someone could build their own like deep research agent using Gemini or different Gemini 2.5 models and the Google search integration. For the example, we used LangGraph, which is basically the agentic library from LangChain. And it makes it quite easy to build composable agents. So you basically define the steps of your agent as simple Python functions, and then you can connect them with each other, or you can also have conditionals based on the output. So if you have like a function which is some kind of like critique or feedback, it can return like an object with like need more research or need less research, and based on like this conditional, you end up in like a different path of your agent, and in the end you have like basically a graph which will be executed when running through your agents. And we build it basically based on the community's request and ask. So if you have any ideas, any wishes on like what we should build with Gemini or help you get started, and like please let us know, or let Ivan know or others. Always very happy to learn from you and like build things which might make it easier to scale your use cases. And when building the deep research agent, of course, what I started with is like, okay, trying to like sketch it out mentally. Okay, how does the process look of researching a topic, and how am I currently doing it like manually?
Okay.
And normally when I want to research or deep research a topic, I start with like, okay, I have my initial like question. Okay, what's the topic? What do I want to research? Okay, let's assume we want to research like what are the latest trends for renewable energies in 2025, right? Then I might also want to research to like what are the trends from 2024, what is related to renewable energies, what are the companies doing research or investing in renewable energies, how it is distributed across the globe, is Europe doing more maybe than Asia or the other way around. So I have many different small queries I need to research first, and I all collect them in some kind of like a scratch pad. And very similar to this, I like sketched out the whole application and built like the different functions for the graph, with having a research function, having this basically scratch pad where you conclude all of the research. And then part of a good agent, at least in my opinion, is always that you use the AI and the LLM to reflect and critique itself. So there was basically a loop between doing a lot of research, creating a report, having the report be critiqued by Gemini based on the initial question and plan. And based on the result of this, either the agent started to do more research, or it basically provided the final answer to the model.
So you basically, if I'm understanding you correctly, you use the agentic pattern of loop agents in this situation?
Yeah, so if we like think about agentic patterns, so we have like the tool use pattern, which uses Google search to do to connect with the external environment to do more research. And then it's more like a self-reflection pattern. So you have like an input to an LLM, and the LLM critiques the output based on a criteria. And depending on the output of the LLM, you either redo the initial task or to continue to the model. And that way we have this kind of conditional flow inside the agent where the model or multiple models decide how many iterations you will do. So it's different to a workflow. Like a deep research workflow could be, hey, generate 4 queries, get all of the information, write a report, give it to the user. The agentic way of doing it is that we have those kind of model deciding if we need to do more research or not. So basically the model has the control over how many iterations you do as part of your research. Of course, you can control it via the application. Developers can limit it or not. Guardrails are very important here because you don't want your agent to endlessly research, right? So you might want to put up like a upper threshold of like, hey, maybe after 10 tries, let's stop.
So, I mean, if I understood well, like based on what you're describing, at the end of the day, you choose to use, in this case, LangGraph because it allows you to build such a graph that probably, using other framework, you couldn't be all, or, it gave you the control that you need on the application for this particular scenario.
Yeah, so I think like most likely you can build the same kind of deep research or similar deep research agent using any other framework. I think it's more about the whole concept on how you scratch it out.
Okay.
I'm sure that like the deep research agent we built is very different to like OpenAI deep research agent or to the other deep research agent. The term deep research here basically just means that we have like not a single Google search and this kind of agentic deep use cases where we have multiple LLMs, agents being part of the whole like conversation, right? If we look at the deep research mode in the Gemini app, there Gemini first generates a plan which you can interact as user, and then it starts doing the deep research. In the example we built, we basically trusted the LLM that, okay, just go and run and like research and come back with your result.
So I mean, based on what you're saying, like you start scratching, the process, and then because the process it was designed in a certain way, you said, okay, with LangGraph, I can control these aspects, so I go with LangGraph. The other interesting part for me is that you mentioned that you have multiple agents, right, in the application. So when do you decide that a multi-agent system was it was the right choice for this kind of application with respect to the single agent system? Like what consideration did you consider? Like, did you?
Yeah, I have to say, like, I am not too sticky with like what's a single agent, what's a multi-agent, what do you use. I think at the end it matters like what you want to achieve and like what's the best way of implementing it. And I think there's always some kind of looseliness between what's a single agent and like what's a multi-agent, right? We define an agent as some kind of control flow where the LLM has decision about what happens next, and it has access to some tools and to some context, right? And a tool can be just a Google search, but a tool can be also another LLM with a Google search. Would this then be like a multi-agent system because the tool is an LLM itself, or would it be just an agent which has tools and which can do other things? And what I like to differentiate between when building agent is like being read heavy and write heavy. And I think based on those kind of like differentiations, you really like start scratching out patterns which are more, I would say, multi-agent aligned and like more single agent aligned. With deep research, we have a very read heavy use case because we want to do a lot of like different searches, reading through documents. So that's a very good use case which you can like parallelize, meaning you can like benefit from like multi-agent design patterns because you can like have some kind of queue with like the different search queries you want to run, and then you can like have independent research agents go and do all of the research and come back with all of the results because they can do it like very independently. When you are more in a read heavy use case, I always like to think about coding. when you use like a coding agent and you have like a React application, for example, and you have your component, which is, I don't know, a few hundred lines of code where you have some business logic in it, you have your template in it, and you have maybe some CSS in it, right? That's a single file. If you now would imagine having like 10 different agents trying to write into the same file, you would most likely end up with a lot of different conflicts. I mean, we already know from Git how challenging it can be when two people try to edit the same file.
Yeah.
Yeah.
So that's why most likely for write-heavy use cases, more like single agents and like sequential patterns are easier to implement because you don't run into those different conflicts. And I think when you start thinking about your use cases, you might be like, okay, I read or write, am I read-heavy or write-heavy? But when you start building out those things, you kind of realize almost naturally what makes more sense for your use case. And it's not that you are like limited by your decision. It's not that you say, okay, I build a single agent and now you need to stick to single agent, or I go with multi-agent and now you can like not shift away. I think the beauty here is that all agentic use cases and frameworks and libraries and examples we are building are very composable. So it's not that, hey, that's this one function which runs. All of it kind of moves towards patterns and decoupled components that you can like mix and match based on your use case.
Yeah, I think it's very interesting distinction. When we talked about it, we had a whole episode in episode 2 about multi-agent patterns. And we talk about, what is the rule of thumb when you decide to transition to multi-agent system? And we talked about, when you have multiple skills and you need multiple like specialties, then you will consider multi-agent system. But what you're saying here, Philipp, is basically you're not looking about that. You're looking more about read or write operations. And when you're heavier in reading, you need multi-agent. When heavier in writing, you will use one. But it's also interesting because you did mention you would use maybe sequential agents in a write operation. So that's also a multi-agent system. So I feel also we need to kind of formalize it more about also parallel agent and sequential agent, maybe, because parallel agent could be good for read scenarios, but sequential agents can be good for write scenarios. Like in code, maybe you want to have one agent which is writing the code and another one that is testing the code or reviewing and providing feedback, and then go back to the first one. What do you think about that?
Yeah, I think we should not be too sticky on like the term single agent and multi-agent. I mean, like we are going later to talk a bit about like the Gemini CLI.
Yeah.
And I think like, is it Gemini CLI a single agent, a multi-agent? As a developer, I don't care.
Yeah,
I'm happy that it can use tools and it can do stuff. And I guess like the engineers building a Gemini CLI are not thinking about, hey, great, we build a single agent coding. It's like, I think we need to move beyond that. Of course, it's very important and helpful when you try to teach and educate people about, okay, what's an agent, what's a single agent system, what's a multi-agent system, for them to kind of understand where we are working and how they are working together and like what are the differences. But I think the whole discussion doesn't need to be that strict, and we should rather like talk about, okay, how can we build cool things, and not like, do I need to build a single agent or a multi-agent system?
Yeah, no, I completely agree. And if we're talking about that, I know that a lot of developers, like you mentioned context engineering, and we're going to touch on that in a minute. But I think the even more basic thing that every engineer does today is prompt engineering, right? Like, even though it's super basic, but it's still interesting. Like, how did you come up with the prompt for the deep research agent, and how do you improve the prompt? Like, what is your secret sauce?
So I think for me, when I write prompts or look into use cases, it now goes down to basically 3 like things. First of all, I do research on similar examples, other people's building cool stuff. Can I extract some kind of patterns? Like using XML tags is becoming very popular to structure your prompt. Can I use those techniques? Then I use Gemini and AI a lot to do prompting. So there are like now different meta prompts out there which you can use to basically help Gemini generate a first prompt for you and then like iterate on it. And then like the third point is basically just try what works, right? I think
Yeah.
with all of the improvings in instruction following and content engineering, it's less about do I use XML structure or Markdown, or more how dense in terms of information the context is I provide. But I like to use AI a lot, and if you have evals, there's nothing better than doing some kind of loop, having the AI kind of critique and update the prompt and try to get like the highest score on your eval set.
Yeah, I actually recently, I love what you said. And I just wanted to mention that recently I saw one of our colleagues actually has a really good blog post about prompt engineering when he's using Gemini, not just to write the prompt for him, using a specific template, but also kind of having a discussion with Gemini, like having some iteration with Gemini on the prompt, like giving some feedback. So we can share that in the show notes as well. But we just thought about that. Yeah, but thank you for your tips. I'm sure developers would find those useful, Philipp. Yeah, so we talked about context also. Can you share a little bit about how did you engineered or design the context in different stages in the deep research agent you built?
Yeah, no, in particular, I'm curious about, before you mentioned, in the past we were talking about prompt engineering, now we're talking about context engineering.
Yeah.
Like, what I notice is that like context engineering is more related to the kind of information that you pass in the context in each turn or each iteration that maybe the agent is going through. And so I really curious about how like you manage it. Like when you were designing the deep research agent, did you think about this like in each state, in each particular state of the agent, what would be like the context that the agent get access to and pass to the LLM? Like all these aspects to me are very interesting when we start building agents, to be honest.
Yeah. So when I was building the example, the term context engineering didn't even exist. And so it's like that's something which is coming up like in I think the last 4 to 6 weeks or something. And for me, it's less about that we have a new term, but it's more that it describes it way better what we are now doing, right? Prompt engineering was a thing like 2-3 years ago where we just had text in, text out, right? So we were investing a lot of time into, okay, what text do we provide? Now with like agents, tool use, multimodality, the whole context changed. And context engineering, at least to me, makes a lot of more sense on like what the actual doing is like, right? If you think you were doing prompt engineering, maybe you're just doing context engineering, and it's not really a change on like how you work. It's more about having a term which describes your work much better than it used to be. And at least for me, when I was building the agent, I know Gemini is really good in instruction following. So I really try to include like rules, instructions, and like the context. So we have a lot of more tokens to play with. So when you like as part of the deep research agent, there's this like one summary step where you have like all of like the different research as part of it. So I know that Gemini can handle a lot of big context, so I can like include a lot of more information into it. And I also always try to, hey, okay, the instruction in the beginning, like what do you want to do, and the instruction at the end to just like emphasize it again. And I have to say, like, since I created it and like today, what I would do today, a lot of things have kind of improved. But for me, like the main part is like, okay, do I have to use or should I use a tool? Meaning, do I want to Google search or do something else? Or do I have a structured output? When building agent, oftentimes it goes down to the output format, and it will be either structured output, meaning you have an incoming text and you want to create some kind of structured data model, JSON, something else, which you can then pass using code to decide the next step or to start something else. Or you have function calling where you want to interact with the environment. And for the deep research agent, it was basically a combination of both. First, I generated multiple like search queries based on the initial user request, and I use structured outputs, meaning you have the user prompt, you have some kind of instruction about, hey, what should a model do? What do you want to achieve? In which environment are we? Which date is today? Because models don't know what is the current date, which is very important if you want to do some kind of deep research, because you want to like use the latest information or not have models say like, yeah, 2020 something XYZ. And the first step, basically use structured output to get like a list of like queries, which you can like then continue into the other agents, which of course then wanted to do some research. So you had like this Google search tool use, and then you kind of like went with it. And when building it, when iterating with it, when testing with it, you notice some kind of patterns. Maybe sometimes the model didn't provide the citations and the quotes correctly. So you try to extend and improve your prompt to be maybe include more rules, maybe include more examples on how it should citate and quote. And then you end up somehow with a prompt at the end. And of course, it's a quick start. So like nothing you want to put in production. We didn't run like big detailed evals on like what works the best. It's more as an inspiration for people to get started and to see how quickly you now can build something, or how can you like get inspired? What are the different building blocks? How could I use those building blocks for my own kind of use cases?
Yeah, and speaking about context, Ivan and Annie talked about memory in the last episode. Have you used any memory in this one, and what are your thoughts on that?
No, like we haven't used like memory in like this use case. I think it would be a cool extension if you are like interested in like, or if you are developers and would like to do more hands-on stuff. I think adding memory could be a very cool use case. If you think about memory on like having some kind of like historical kind of memory. So like memory, basically, I think Ivan talked about it, gives us the opportunity to include external persistent information. Like normally a conversation with an LLM or an agent is like stateless. So it only knows what we provide and has no idea about if you like did a deep research or a question like a few minutes ago. With memory, you can include those kind of information. So if we know that like a user, I don't know, prefers some certain style of output, like I always want short bullet points, not longer than 200 words. Those kind of information could be included when building up some kind of memory context, and then it would be very personal to all of the different users. So I'm like a big fan of memory. I think it's super hard to get it right because you do not directly get feedback. It takes much more time to build up a memory system to get feedback and to give it to your users. And then like similar for the user, we have always higher expectations. So the memory improvements and features come very indirect for us, right? We maybe start noticing some change. We really prefer the updated parts, but we don't know that the improvements come from memory and not from like prompt changes and model capability changes. So with memory, I think it even will get harder on the evaluation side and observability side to kind of understand, okay, do improvements come from included information through a memory system, or do they come from like a different part?
I see. So, I mean, according to what we just discussed, at this point, you decide, the capabilities of the agent, you choose the framework, you went through this development process to figure it out prompts, and you also engineer the context, choosing like with respect to the tools that you were considering. So I would say that at this point you got like a prototype of the agent, right?
Yes.
So one thing that you touch is that, the evaluation part. So before, let's say, to get the agent out and get it published on GitHub as a inspirational example, as you said, which kind of evaluation did you run? Because evaluating a deep research agent, it sounds like a little bit tricky, to be honest.
Yeah.
It's very
Yeah, so I would say we did only the minimal amount of evaluation. So I tested it a lot. I still use it, I have to say, for some like, I would say, light search. It feels like very nice and easy to use. And it turns out it's very good instructable. So I have like a lot of like impact on how the response is formatted, which I really prefer. And then we had our team like play around with it, test it. And I think we did around like 10, 15 different like experiments, like read the response and then like kind of pushed for it. Of course, if you have more time, it would be great to do some kind of like structured testing where you decide for like different search queries or have LLMs generate those search queries, get the result, and then like kind of score the result, that you can set up some kind of LLM as a judge pipeline. I also know that there's now an open deep research benchmark, which could be very interesting to run against the agent. But yeah, like evaluating deep agent or deep research is very time intensive, and we really wanted to like push out how people could build this, as we know it's like just a prototype and a quick start to get people started.
Yeah, I think that evaluation is one of the most sensitive points that I've been seeing with the agent development and AI development in general, because engineers are usually used to just, building things, building some logic and shipping that. And then, you need to kind of more consciously think about, hey, I need to evaluate different scenarios. I need to have some metric to try to predict how it would work online. And it's pretty challenging building those benchmarks that you mentioned, Philip. And we can use LLM as a judge methods, which could be very helpful. But also, how do you know that the LLM is actually a good judge, and judging the LLM capabilities for that? So that's a important question. How did you know that your agent, the one that you built, is ready to be published outside? Do you have like sort of a threshold, and when is it ready?
Yeah, I mean, well, actually, like the point is, you get this cool prototype, right? When a developer should be confident, to say, okay, this is a very good baseline, is a good starting point. Let me just publish it. Let me just open and see what happens. That's a kind of the question that I keep receiving.
Yeah. I think for me, it's like always ship, iterate. Like you will never get better feedback as the one from real users, right? Of course, it's like not always as easy, especially if you are more critical environments.
Yeah.
But what we see, or I saw most success is, of course, if you build agents for yourself, you are your biggest user. And you should be your biggest users, because then you kind of experience and understand how it works. So, for example, I have like many small agents I run on like my MacBook, which do many small tasks, like doing some like online research, doing some social media research, trying to collect some news, like things I used to do manually, which I kind of now like try to automate or scale. There I'm the biggest user. I design it for myself. And similar things can be done like with a very small group of people. And then I think people in general, or users, if it's like not super critical, are very happy to test and to provide feedback to stuff, right? Of course, if you have like a chatbot on your car delivery company and want to use it as a customer support agent, you should probably put not your first prototype into production and have like a car sold for like $1 or something. That's like a way more critical use case. But even on that scale, you can like start maybe with like 1% of like your customer interaction, shadow, like kind of simulate through like your agent, right? We always think about agents on like interacting with humans, but what if we can like start from a human interaction and have some kind of LLM simulate the user, and then you can basically have the LLM chat with your agent and see how things could evolve, or have LLMs try to expose your agent. And I think that way you can like scale it very easily to different amount of use cases, collect more data, and then iterate. Of course, like shipping means many different things in like many different environments. For me, at least on the DevRel side, we want to ship things to developers so they can get inspired, can learn, can integrate artifacts into their own work. But if you work more in like a company environment or an enterprise environment, shipping, I think, could also just mean from your laptop to another teammate, could also be just focused as on shipping.
Yeah, I love those observation. One, it depends of the risk level of the model. Like if it's a low risk, you can just test with a bunch of your customers. If it's a high risk, then you might have to reach a higher bar. And also like what you said about, first of all, dog food, try your own. And I'm also very curious about what you said. What are all of those little agents you have on your computer? Can you share with us, and how did you build those?
Yeah, so I have like a newsletter agent is what I call it, but the idea is like as part of my job, or in general, because I'm very curious and passionate about AI, is like, okay, how can I collect all of the insight and trends, what's going on in AI? Like if you are part of AI, it's like very noisy. There's so much more information. And like my idea was like, okay, can I automate? Can I have some kind of browser agent which goes to like Reddit, to Twitter, to subscribe to different newsletter and like create some kind of bits for me, which makes it easier to follow like what's interesting. So that's like one example, for example.
Yeah, I also built this kind of agent. I built one like this for the podcast when we just started this. So cool.
It's pretty exciting. It's pretty exciting what you can do with this. But
Yeah.
talking about agents that doesn't run, or maybe they run also on our laptop. Like recently we released the Gemini CLI. Actually now is some months, and I just want to know, like, first of all, what do you think? And second, like, if you can talk about how are you using it, what are your favorite features?
Yeah, so I'm a big fan of the Gemini CLI. I think it's like super cool that we released it open source right there. I think every foundation model labs now has some kind of coding CLI agent, right? There's Codex, there's Claude Code, there's Gemini CLI. Even open model providers have their own like CLI with like Quen Code, which is I think really cool because it's like a fork from Gemini CLI. So I was very happy that we were able to open source it to make it accessible to people. And like the strong benefit here is like as a developer and user, I can inspect what's going on, right? We can look into the system prompt, we can look into the tools, which makes it much more understandable to me why Gemini or Gemini CLI does certain things. And of course, it's extensible. And we see the community being very active. So we get feedback and code contributions back from the community, which of course benefits everyone at the end. And to me, it's very cool because Gemini CLI, I think, is the first agent at Google we released, which is used externally by third-party developers, but also internally at Google in different like teams and different use cases. So like both Google engineers internally and software developers externally use the same tool, and we all contribute to it, making it like, or hopefully making it the best coding CLI at the end. And to me, it was like a real blessing to use Gemini CLI internally at Google to do documentation work. So we have the Gemini API docs, and nothing is cooler than using an AI to update its documentation itself, especially. So you can think about like a very typical use case is we release a new Gemini model. Then we, of course, need to test all of the code snippets, review all of like the different informations we have, and update all of the model ideas, which is a very repetitive, painful task. And it's very easy to make mistakes, no matter how good of an engineer you are. And with Gemini CLI, we can now like automate this kind of work, or like semi-automate this work where we tell it like, okay, that's what we need to do. Please go. And Gemini CLI reads like the different files and then updates the model IDs. And then we still had like the code snippets. And with the base Gemini CLI version, you can like execute code, but maybe you don't want to execute code on anything or your device. And with Gemini CLI supports like MCP servers. So I built a small MCP server which can run code and integrate it into my workflow. And now I can have Gemini CLI run its own code snippet, which calls Gemini again, which makes it super nice to like update and validate those snippets.
Yeah, that's so cool. I love what you said about, how Gemini CLI is a tool that both external folks and internal Googlers are using. I just saw that like a couple of days ago when we found some gap in one of our internal libraries, and one of our developers just, came up with a fix to that using Gemini CLI. It was another team's library, not our team's, and he just open contributed. So I think this is something amazing that Gemini CLI is enabling, and I love the work that you did with the MCP server. Can you tell more about that?
Yeah, so I mean, I think it's like very cool that we can do all of those works. Of course, I mean, you mentioned you built your newsletter agent. I have my newsletter agent. I think it's so cool that we can do all of those small little things for our individual use cases. And the idea I had is that, hey, I have code I need to execute, and you don't want to execute arbitrary code on your own machine. Maybe even if the code is very defined, what if, for whatever reason, it wants to delete something? Or what if my local environment is different to the one from the user, right? What if I have a different SDK version installed? So I wanted those ephemeral environments where I can execute code. And there are many, many startups trying to solve this because it's a very common agent use case. We also have a tool for it in the Gemini API with code execution, but I needed a bit more flexibility, and I also didn't want to pay because I mean, it's just a small code snippet. It's nothing specific. I don't need to scale it. It's only my use case. So I was doing some research on like, okay, what can you do? And of course, like Docker and container are very good in running code, which is completely decoupled from other parts. And there was this like open source library called LLM Sandbox, which someone wrote, which is basically a Python library which uses the Podman and Docker SDKs to start and stop containers and execute code. And then I basically used that library, wrapped an MCP server around it with the tools for my use case, and also made it a bit more configurable for my own environment. So I wanted to test Gemini SDK. So I built a Docker container which has the Gemini SDK installed. And I also added a way to add API keys, and then are now running it like as a local MCP server, which the Gemini CLI can use to execute Python and JavaScript code with the container I used. And basically what happens behind the scenes is that Gemini generates the code it wants to execute, hands it over to the MCP server. The MCP server starts a fresh, clean Docker container, creates a Python or a Node file inside a container, and then runs the command to run the code. And all of the printouts or stoodouts are provided back to the Gemini CLI as output. So if there's an error in the code execution, Gemini CLI would get back the results and the error and can then iterate on it automatically, trying to fix the code snippet using the available documentation, or just trying to find maybe a syntax error or something.
No, sounds pretty exciting. And just because, I mean, for people that are watching or listening, like, what was your experience to use MCP with Gemini CLI? Like, how smooth it was? What suggestion do you have, like, for new developers that is trying to integrate MCP with Gemini CLI?
I think it's super easy. Like, it's basically you have a JSON file either in your project or like in more globally in your home directory where you can define the different MCP servers. I also know that since the latest or previous release, there's a new command. So if you have run like Gemini/MCP add or something, you get some kind of wizard which guides you through all of the information you need to add your own MCP servers. And then, of course, there's documentation, and you can always use Gemini CLI to ask it, hey, if the MCP server doesn't work, why doesn't it work?
Yeah, that's so cool. So can you tell us what are the features you like the most about Gemini CLI?
Of course, the MCP support. And now, since I think 2 releases ago, we have something called custom commands, right? When you work with LLMs or agents, you need a prompt or a context. And it is very painful if you always need to rewrite those prompts, or if you have already created some kind of context and prompt with like some instructions, some rules, some files you want to read, or maybe some information or documentation about a specific library. And with custom commands, you can now create TOML files, which are basically a template file where you can provide all of the context, information, links to files, and then you can directly use them. And I created some kind of plan develop mode where I have a long prompt and context about rules, guidelines, and instructions for Gemini first to create a plan and write it to disk with all of like the implementation details, what it would change, and then an implement template as well. And it's super nice to integrate it, similar to like the native commands with like /MCP. You have like / and then whatever you called it. And then you can like directly interact with it, and you can also provide snippets. So if you are, I don't know, a front-end developer using Tailwind CSS, you can basically have some kind of special plan for like the colors or plans, the classes you want to use, and then create a template for it, put it into your project, and everyone from your team can use it, and you can directly use it, which makes it, at least for me, much faster to iterate on those different use cases.
Yeah, I love that customization ability. It's much more personalized because you're basically bringing Gemini into your command line and, co-developing with it. So it's much more easy when you can actually tell it, how do you like to code? What tools do you like? How do you prefer to interact? And that customization option is really cool. Yeah. So what is the coolest thing you built with Gemini CLI?
I think for me, the coolest thing is really that I can use it internally and be a lot faster on updating documentation, updating examples, creating new quick starts. I really feel that I'm faster and more productive being able to use it. I haven't like fully automized it, so I still use this, I would say, interactive mode where I look at all of the commands Gemini would run and then decide, do I want to run it or no? Because as a developer, very familiar with the code base, it's much easier if you see commands or indications that the model might go in the wrong direction, that I can like just interact with it and say, hey, no, please look at this file or do that, instead of like having it run and then like look at the result.
Yeah, no, this to be honest, like this aspect of control for me is it's very compelling when I use the Gemini CLI. And another aspect that is the last one that I want to touch with you is that, I mean, at the end of the day, Gemini CLI, in order to solve a particular task, it goes through multiple iterations, right? So, which implies that it will also potentially generate high cost. So, like, how do you manage this aspect while you are developing? Like, when you use it, like, you think about that, right?
Yeah, I mean, like I have to say, I mean, since I work at Google, we have like a quite more flexibility in how much Gemini we can use, especially at DeepMind. But I know like for the Gemini CLI, it's like I would say, multi-provider kind of system. So you can use it with your Gemini API key from AI Studio. You can use it with your Vertex AI project when you have like Gemini. There's the Gemini Coding Assistant where you can subscribe to and use directly. I would say if I would be external and independent developers, I would look for a plan which is based on a flat fee. Especially currently, they offer way more like flexibilities. And then like look at my usage. I know when you like close Gemini or like stop it, we will always get a very nice short report on like the number of tokens you used, input and output, which can help you understand your costs quite easily.
Yeah.
Yeah, that makes sense.
Yeah, so I think we're done with Gemini CLI, right? We don't have any more questions about that.
Not on our side, at least.
Yeah.
I mean, something I can add, and I think this goes out to every Gemini CLI user, even if you tested it like 2 weeks ago, 4 weeks ago, 6 weeks ago, you should try to follow it. Like, it's really crazy to me to see how fast the iterations are by the team, and they push out basically weekly releases. And the most exciting one, like recently, was last week, where they added IDE integration. So if you use VS Code, you now have like a nice extension where you can like view the changes Gemini CLI makes in your IDE and not in your terminal anymore, which is very nice if you work on like, I would say, more markdown kind of updates and not code directly.
Yeah.
Yeah. So the message here: go out there, try Gemini CLI. It's so cool.
Yeah, and like keep following.
People, definitely. I've seen the increased productivity in my team using Gemini CLI, so definitely recommend to try. And now for one of our favorite segments, the developer Q&A, where we take questions directly from our developer community. We put out a call on LinkedIn asking for your toughest question for Philipp. Philipp, are you ready?
I'm ready.
So here is a great question coming from Conrad Deputer, a senior staff AI scientist from Intuit. He's asking, is it possible or worthwhile to attempt to write a model-agnostic prompt? One issue in scaling agents to prod is capacity limits for individual models, like we just mentioned. Being able to swap from, say, GPT-5 to Sonnet seamlessly could help with scaling, but at the moment, an optimized prompt from one family of models seems to perform terribly with any other family. Have you seen any complex agent which are able to swap out model families without significant loss in performance? If so, what are the tricks? If not, do you anticipate any convergence in prompting standards? I think that's a very
long,
challenging question.
Yeah, I think we can like take it step by step. First of all, I can feel and know the pain of like creating a good prompt, model update, model changes, and you need to iterate on it. I think the right way to look at it is like not writing one single model agnostic prompt. It's more like, can I set up a process which allows me to optimize my prompts automatically for different models and use cases? And I think if that's the question, then yes. Like there are now like tools, libraries out there which can help you automate prompt optimization. And all goes again back to like evaluations, right? I can totally understand if you go from like GPT-5 to Sonnet that the GPT-5 prompt will work differently on Sonnet 100%. We know Claude is very favorable of XML tags. I don't know about GPT-5. I would assume it's still very good with those, but maybe not as good. And I think it again goes back to, do I have some kind of evaluation set for my agents? And then can I create some kind of nice process where I have my new model, I have my evals, how can I find the best prompt? And for this, I can use AI and libraries that help me automate those prompts automatically. And then I don't need to sit down and do all of the work manually.
Yeah, and this is a kind of a common issue that not only developers but also customers on Google Clouds they have. We try to solve with releasing these services, which is Vertex AI Prompt Optimizer. But essentially it approached the problem as Philipp was saying. So you can use like a plain LLM to refactor the prompt, as well as if you have some data of the previous interaction between different models, you can use this data in an optimization process that will allow us to migrate your original prompt to a target model. But it's an open problem for sure. It's an open challenge.
And I think even something I want to add here is you might still want to look in prompt optimization even if you're on the same model, right? We talked about earlier how user expectations change, how the data drifts. I think the same can be said for like same model, same use case, same prompt. You want to update and optimize your prompt or your context all the time because the expectation changes, the input changes. So you need very good tracing, you need some kind of eval system, and then you can build those kind of automated pipelines which will help you scale and optimize your prompt.
So you are on an ongoing basis. When the model is in production, you monitor the performance, and then there's like some kind of a flag or an anomaly that's raised telling you, hey, you need to optimize your prompt, and then you see like you have like an automated pipeline to optimize.
Yeah, like agents are living artifacts. Like it's not because you put an agent into production, it's done. Like we have like a much more dynamism to like the user inputs than to traditional software, right? My microservice, I don't know, processing customer requests might always work the same because the inputs are always the same. Now we have this new paradigm where user inputs can be so much more different and evolve over time with the change of expectation. And it's like the same we had with like the chatbots. Like beginning, we are like super impressed by being able to like count 2 + 2. And now we basically have those models participate in math Olympiads, which is like a complete change of like expectations. So agents are always a living artifact, which you always need to improve.
It's interesting how we start with expectation and evaluation, and we are closing this episode on talking about evaluation.
Yeah, evaluation is always the key factor. Yeah, so that's all the time we have for today. Philipp, it has been an incredible deep dive into the real challenges developers are facing with agent development. Thank you so much for joining us and sharing your expertise.
Yeah, thank you, Philipp. It was a very great conversation.
Awesome. See you.
And that's all for today. So, Philipp, thank you again for being with us today and guiding us through all these challenges that developers are facing in building, but also shipping agent. It was such a pleasure to have you.
Yeah, and a huge thank you from us and the entire Agent Factory community.
As always, we will share all the resources, including Philipp's blog and social media in the show notes. And for everyone that is listening, be sure to follow us on LinkedIn and X to submit new questions for future episodes. As well as don't forget to subscribe to Agent Factory, whatever you're getting your podcast, so you're not going to miss the next one.
Thanks again for tuning in to the Agent Factory. Powering down.